I'm Jasmine Smith, and this is Math 1000 Quiz 6 makeup. So the problem is to find the integral from 0 to pi of e to the x sine 2x dx. And you're going to do this by using integration by parts, which is uv minus integral of v du. So I chose sine 2x for my u, and for my dv I chose e to the x dx, making my v e to the x and making du cosine 2x times 2. So when I plug everything in, I get sine 2x times e to the x minus the integral of e to the x cosine 2x times 2. And I took out the 2 as a constant, leaving me with 2 times that integral. And with this part that you're left with, you're going to do another integration by parts, and your u is going to equal cosine 2x, du is going to equal negative sine 2x times 2, and v is going to equal e to the x, making dv equal e to the x dx. So you're going to bring in that, you're going to bring down that sine 2x times e to the x, and you're going to multiply the second part of this, you're going to multiply the second integration by parts by 2, since you multiplied this part by 2. So you bring that down, and it's going to give you, once you plug everything in, cosine 2x times e to the x minus the integral of e to the x times negative sine 2x times 2 dx. And again, you bring out the 2, making it 2 times cosine 2x times e to the x plus 2 times the rest of the integral. So at this point, you are back to where you started once you take that 2 out again with the integral of e to the x times sine 2x. So what you're going to do is I just showed where I brought that down, showing that you got back to the beginning. And you're going to bring each piece down, and I just rearranged this so it's e to the x sine 2x minus 2 e to the x cosine 2x minus 4 times the integral of e to the x times sine 2x dx. And the reason where you get that 4 from is when you factor in, or when you multiply out this 2 right here. So you're going to get that to this piece right here and this piece right here. So since you have the same thing right here, since this 4 is on the outside as a constant, you have the same thing here and here. So you're going to multiply this part over to here. So since it's 1 of these and 4 of these, you get 1 plus 4, which equals 5 of course, times the integral of e to the x times sine 2x equals e to the x sine 2x plus 2 e to the x cosine 2x. Okay, so I'm again just bringing this all the way down, the original integral that you're supposed to be finding, and I'm going to divide that 5 out that you had here, that we had here. I'm going to show that. The 5 that we had here, I just divide that out, divide each side by 5, so the 5 is going to go away here, and you're going to get 1/5 here and 2/5 here as coefficients of this section of the problem. So you're going to end up with 1/5 e to the x sine 2x plus 2/5 e to the x cosine 2x. So now you're, remember the integral is from 2 to pi. This is a definite integral. So you have already integrated, so you show that by this line here instead of an integral sign out front. So you're going to have this from 0 to pi. So you're going to plug in pi first, minus everything, minus the equation minus the integral plugged in was 0. So what you're going to get for this piece is 0, and for this piece is 2/5 e to the pi. I wanted to keep that as simplified as possible without getting a decimal or anything. And this is going to be 0, and this piece is going to be 2/5. Yeah, and so what you're left with when you put this all together is the negative 2/5 e to the pi plus 2/5. Okay, so I just distributed out the 2/5, and the answer is 2/5 times negative e to the pi plus 1. So that is the integral using integration by parts of e to the x times sine 2x dx from 0 to pi.